Welcome back for another deep dive. This time, we're going way back, like ancient Greece back,
Mm.
to uncover the, I guess you could say, unexpected history of their mathematics.
It's a history that's, well, far more relevant than people often realize.
Right. Like when you hear Greek math, you might think, oh boy, triangles and equations, here we go. And it's so much deeper than that, you know?
Absolutely.
We're talking about using math as this lens to try to make sense of, well, the entire universe, really.
The pursuit of knowledge,
Hmm.
it was truly a holistic endeavor. Math, science, philosophy, it was all interconnected.
Totally. And to guide us through this deep dive, we're working with excerpts from the book, The Story of Western Science. Plus, we'll be, diving into some of those core Greek mathematical concepts along the way. So get ready because things are about to get, well, pretty fascinating. And our journey begins with Thales. Now, he's often called the father of Western philosophy, but you could also make a case for him being like the OG
He
scientist.
really shifted the paradigm.
Oh, yeah. In what way?
Well, you see, before Thales came along, if there was a huge storm, people would just say, oh, Poseidon's angry. They'd attribute these natural phenomena to the whims of the gods, right?
Right. Right. Makes sense for the time.
Exactly. But Thales, he was like, hold on a minute. What if instead of blaming Poseidon, we try to find a natural explanation for this storm?
And that was a big deal, wasn't it? I mean, we're talking about a major shift in thinking. That's what's called Thales' leap, right?
Exactly. Now, his theory that everything in the universe was made of water, well, that didn't quite hold water, so to speak.
Yeah, I guess we know a bit more about that now.
But it was his approach that was revolutionary. Thales, he really set the stage for scientific inquiry by looking for natural explanations. And that's a
Huh.
legacy that, well, it continues to this day.
Like he lit the fuse, and then boom, the fire of scientific inquiry just took off.
It's a powerful analogy.
Now, to really understand Greek mathematics, we got to delve into their unique perspective, what's the word? Their fascination with ratios. See, it's quite different from how we often approach math today.
It is indeed. Today, we tend to fixate on absolute measurements. Like, we describe a rectangle as, say, 8 centimeters long and 4 centimeters wide.
Yeah, length times width. Everyone knows that.
Right. But the Greeks, they were more interested in the relationship between those lengths, the ratio, rather than the specific measurements. So that same rectangle, they describe it by its ratio of 2.1, a relationship that remains true no matter what size the rectangle actually is.
So it's less about the actual numbers on the page and more about uncovering a deeper truth, some kind of like underlying code to the universe.
Precisely. This focus on ratios underscores their quest for universal truths, truths that transcend specific instances. For them, ratios, they represented this deeper order behind the often chaotic appearance of the world.
Okay, I'm starting to see why that would be so appealing. But speaking of appealing, let's talk about the Pythagoreans. Now, these guys were more than just mathematicians. They were practically like a philosophical rock band with their own set of, well, let's say unique beliefs. Vegetarianism, reincarnation, numerology, you name it. They were into it.
They were a fascinating blend of mathematical brilliance and, shall we say, unconventional thinking. They saw the universe through the lens of numbers, convinced that those numbers held the keys to unlocking, well, everything.
And they weren't just, sitting around meditating on numbers. These guys made serious contributions to mathematics. We all remember the Pythagorean theorem, even if it's a bit foggy from high school.
Right, a squared plus b squared equals c squared. It's one of those formulas that sticks with you.
Exactly. But they didn't just stumble upon it, they rigorously proved it, right?
They did. And that was crucial. See, while knowledge of this relationship existed before them, they demonstrated that it was a universal truth. No matter what right-angled triangle you looked at, no matter how big or small, the Pythagorean theorem held true.
Talk about a commitment to finding solid proof. But it's interesting, this quest for absolute certainty in mathematics, it actually led them to something that shook their entire worldview.
Oh, they stumbled upon something big, something that threw their whole system into question irrational numbers.
Irrational numbers. Okay, now that sounds a little ominous, even for math. Tell me more about these irrational numbers and what made them such a big deal.
Well, you see, the Pythagoreans, with their whole thing about ratios, they believed that all relationships in the universe, especially in geometry, could be expressed as ratios of whole numbers, like nice and neat.
Okay, makes sense. Ratios were their jam.
Exactly. But then they stumbled upon this mathematical paradox that just completely threw that belief out the window.
Oh, a paradox. Mathematicians and their paradoxes. So what was this paradox that managed to, like, unravel their whole system?
Or picture this. You have a right triangle, right? And both the shorter sides are the same length. Now try to find a single unit of measurement that perfectly fits both one of those sides and the diagonal of the triangle.
Okay, got it. One side and the diagonal. What happened? Did they find that magical unit?
They did not.
Yeah.
No matter how hard they tried, they couldn't find a common unit. It's
Yeah.
like the relationship between that side and the diagonal just couldn't be expressed as a simple ratio of whole numbers. They called these lengths incommensurable. And essentially what they had stumbled upon was the existence of irrational numbers.
Irrational numbers, numbers that just, like, defied their whole system of perfect ratios. Talk about a reality check.
It was a huge deal for them. There's even a story, maybe a legend, that when one of the Pythagoreans, a guy named Hippasus, revealed this discovery to the outside world, well, let's just say his fellow Pythagoreans were not happy about it. Some stories even say they silenced him permanently for spilling the beans.
Wow, talk about intense. I guess some mathematical truths are harder to accept than others. It really makes you think about how challenging those deeply held beliefs, even in the pursuit of knowledge, can be met with, well, let's just say resistance. But moving on to another giant of Greek thought, let's talk about Plato. How did he view mathematics and its role in the search for knowledge?
Plato, he was a different breed. He believed that the physical world, one we experience with our senses, was just a shadow, an imperfect reflection of a higher realm of perfect, unchanging forms. He called this realm the realm of ideas.
Okay, so it's like the physical world is like a rough draft, and the realm of ideas is the final perfect version.
Exactly. And for Plato, mathematics, especially geometry and arithmetic, these were the tools to bridge that gap, to access that higher realm.
So instead of using math to, like, measure and build things in the physical world, he saw it as this path to transcend the physical altogether, to touch these pure abstract forms.
Exactly. Think about a circle, right? You draw one, it's always going to be a little bit imperfect. But the true essence of a circle, the perfect circle, exists only in the realm of ideas. And for Plato, mathematics, that was the key to unlocking that perfect realm.
It's a very different way of looking at math than, what we usually think of today. It seems like he was almost, I don't know, suspicious of applied mathematics, like using math for practical purposes somehow tainted its purity.
There's definitely some truth to that. Plato, he worried that too much focus on observation and experimentation would distract from the pursuit of true abstract knowledge. That's actually why he wasn't a huge fan of astronomy as it was practiced back then. Too much reliance on observing the stars, which he thought could be deceiving.
So, for Plato, true understanding, it came from within, from the mind's exploration of these perfect forms, these eternal truths, not from looking outward at the, let's face it, often messy and confusing physical world.
It's amazing how these different approaches to knowledge can coexist, shaping the way we think. And speaking of shaping knowledge, we can't talk about Greek mathematics without talking about Euclid. His work was just, well, revolutionary.
No doubt about it. Euclid's Elements, it was a game changer. He took centuries of accumulated geometric knowledge and organized it all into this clear, logical system. It was groundbreaking.
He basically invented the geometry textbook, didn't he?
You could definitely say that.
Yeah.
And the impact of Elements is just incredible. Think about it. It was a cornerstone of mathematical education for over 2,000 years. What made it so powerful was its accessibility. Euclid, he laid out geometric principles systematically, starting with basic definitions, then building up to these complex theorems. You didn't need to be part of some secret society or have some mystical knowledge to understand geometry anymore. Euclid made it clear for everyone. He democratized knowledge, and I love that. It reminds me of that story about Euclid and King Ptolemy III. The king was, struggling a bit with the intricacies of geometry, and he asked Euclid if there was like an easier way to learn it, a shortcut. And Euclid famously replied, "There is no royal road to geometry, no shortcuts, not even for a king."
I love that story. It perfectly captures Euclid's belief in the power of logic and how in mathematics the rules are the same for everyone. And his work, it paved the way for future mathematicians to keep building on that foundation. And one of the most remarkable figures to do just that was Archimedes.
Oh yeah, Archimedes, the Eureka guy, the one who supposedly jumped out of the bath and figured out the principle of buoyancy. But his genius, it went way beyond just that one, albeit famous, moment in the bathtub, didn't it?
Oh, absolutely. Archimedes, he was the definition of a polymath. Mathematician, physicist, engineer, inventor, you name it, he excelled in it. What made him so brilliant was his ability to bridge that gap between abstract theory and the real world. He took Euclid's system of geometry, and he wasn't afraid to apply it to real-world problems. He wasn't content just contemplating shapes on paper. He wanted to see how those shapes functioned in the real world.
Didn't he also famously calculate how many grains of sand it would take to fill the entire universe? I mean, talk about thinking big.
He did. It sounds crazy, right? But that was Archimedes. He even developed a whole new system for expressing those massive numbers because the Greek numeral system just wasn't up to the task. That's how far he was pushing the boundaries. He was a true original, always driven by this insatiable curiosity.
And he was also one of the early proponents of the heliocentric model of the universe, wasn't he? That was pretty radical for his time.
He was. Most people back then, even the really smart ones, were stuck on the idea of an Earth-centered universe. The fact that Archimedes was open to a model where the Earth revolved around the sun, well, that shows you just how independent his thinking was.
Centuries ahead of his time. It makes you wonder how many other groundbreaking ideas got lost or dismissed throughout history simply because they didn't fit with what everyone thought they knew. But Archimedes, he reminds us that real progress often requires a healthy dose of skepticism, that willingness to question even the most widely accepted truths. And speaking of questioning accepted truths, our last stop on this deep dive takes us to Ptolemy, a figure whose work had this incredible, long-lasting impact on the world.
Ptolemy, he's a perfect example of how even a flawed model can have a huge influence, especially when it seems to provide a sense of order and predictability.
Okay, now you've got me curious. Tell me more about Ptolemy and this impactful but flawed model of his.
Ptolemy, well, he was a Greek astronomer, mathematician working in Alexandria, around the 2nd century AD. And he wrote this book, The Almagest, that became like the go-to text on astronomy for over 1,000 years.
1,000 years! That's like unheard of. What made the Almagest so influential for so long?
Ptolemy, he had this ambitious goal, you see. He wanted to create a model of the universe that was comprehensive, something that could accurately predict the movements of all those celestial bodies. And the amazing thing is, to a large extent, he actually pulled it off. The catch, his model, it was geocentric. Earth right there at the center of everything.
It's wild to think about that now with what we know about the solar system.
I know, right?
Yeah.
But back then, that was the prevailing view. And Ptolemy, he didn't just accept it. He went all in, developed this incredibly complex and mathematically elegant system to support that geocentric view. And honestly, for its time, his model was surprisingly accurate, especially considering they were working with, just the naked eye to observe the cosmos back then.
Makes sense that people would hold on to that. It gave them a sense of order, a way to explain the movements of the planets, which I imagine could seem pretty chaotic otherwise.
Exactly. But to make that Earth-centered model work, Ptolemy, he had to get a little creative. See, the planets, they don't always move in a straight line across the sky. So to explain those kind of loopy movements, he came up with the idea of epicycles.
Epicycles. Okay, now you've got to explain those.
All right, so picture this. You got a planet, right? And it's moving in a small circle, and that circle, that's called an epicycle. But here's the thing. While that small circle is moving, its center is also moving along a bigger circle around the Earth. And that bigger circle, that's called the deferent.
So it's like a circle moving on another circle, like some kind of cosmic carousel.
Yeah, that's a great way to put it. And if that wasn't complicated enough, to really fine-tune his model, to explain those slight variations in a planet's speed, Ptolemy, he added another layer, the equant. Now, the equant, it's this imaginary point, and it's not even on Earth. But from that point, a planet would appear to be moving at a uniform speed.
It's like they were coming up with these, I don't know, more and more complex ideas just to try to make their observations fit with this idea that Earth had to be at the center of it all.
That's exactly it. And the funny thing is, it worked. Ptolemy's model, it might have been based on a flawed premise, it might have gotten super complicated, but it made these really accurate predictions. And because it seemed to work, his model, well, it remained largely unchallenged for something like 1,400 years.
Over 1,000 years. Wow, that's incredible. It just goes to show you how a model, even one that's, well, not entirely accurate, can still have this huge impact, especially if it creates this sense of, like, order and predictability. It makes you wonder what assumptions we're clinging to today, maybe without even realizing it, that might be keeping us from seeing things in a whole new light.
Right. It's something to think about. Ptolemy's story, it reminds us that progress, well, that doesn't always follow a straight line. Sometimes, to really move forward, you need to be willing to, shake things up, question what seems unquestionable, even if it means turning your whole worldview upside down.
We've covered so much ground in this deep dive. from Thales, who dared to imagine natural explanations for things, to the Pythagoreans wrestling with those mind-bending irrational numbers. We explored Plato's world of perfect forms and Euclid's mission to make knowledge accessible to everyone. And then there was Archimedes, measuring the universe with his grains of sand, and finally Ptolemy, whose model, even with its flaws, shaped astronomical thought for over a millennium.
It's been quite a journey through the history of ideas.
It really has, and through it all, one thing remains constant: the very human need to understand the world around us. Whether we're trying to make sense of the stars or unraveling the fundamental mysteries of the universe, it's that relentless pursuit of knowledge that drives us forward.
And as we've seen today, it's often in those moments when we dare to question, when we embrace the unexpected, that we make those truly groundbreaking leaps in understanding.
Couldn't said it better myself.
Yeah.
Thanks for joining us for this incredible deep dive into the world of ancient Greek mathematics. It's a journey that reminds us that sometimes the most unexpected discoveries are hidden in plain sight, just waiting for us to look at things a little differently. Until next time, keep questioning, keep exploring, and most importantly, keep seeking out those aha moments.